Imagine writing just a single line of code, like a really simple hello world loop.
Right.
And just by doing that, you accidentally launch this massive cyber attack that takes down a multi-million-dollar cloud server.
It sounds like a bad movie plot,
Yeah.
honestly. But it's a very real scenario when you start letting everyday users, just run arbitrary code on the web.
Right. And that's exactly what we're getting into today. We are looking at how AI is giving, everyday users the power to build custom software on the fly.
Mhm.
We're doing a deep dive into a really fascinating piece by Jeremy Morrell. It's from August 2026, titled Extensible Software in the Age of LLMs. And our mission today is really to understand how software is transforming from these rigid, static monoliths into something entirely squishy.
Squishy, yeah. I love that word for it.
Right. But more importantly, we really want to unpack the absolute security nightmare of actually letting people execute that squishy software on the open web.
Yeah, because the motivation behind this whole shift, it really stems from a fundamental flaw in how web development works today.
Okay, what do you mean by a flaw?
Well, developers have a finite amount of time, right?
Mhm.
So they are forced to build features that serve the top of the demand curve. They have to build for the masses.
Which leaves this massive, endless long tail of unmet individual needs.
Exactly.
Because if developers actually tried to accommodate every single user request or, every tiny workflow tweak, our modern web apps would turn into this absurd Swiss Army knife.
Oh, yeah.
Like you just want a little blade to open a package.
Right.
But you're handed this bowling ball-sized clump of metal with like 3 magnifying glasses, a corkscrew, and a tiny plastic toothpick that you're never, ever going to use.
And it becomes completely unusable for everyone.
Exactly.
And that limitation is actually what led Pete Kumin from Y Combinator to coin this concept of small software.
Small software. Or I think other people in the industry call it software for one, right?
Yeah, software for one. The idea is that we shouldn't have to compromise on our unique workflows just because we're part of a massive user base. And large language models, LLMs, are finally making software for one a reality.
Because they bypass the whole enterprise process.
Completely. They completely short-circuit the traditional enterprise development cycle. You can basically bypass the support tickets, the product managers, the endless meetings, and just have an AI build a bespoke tool tailored exactly to your personal workflow.
So if standard web software is this rigid, unchangeable Swiss Army knife, how are LLMs actually changing that day-to-day user experience? Because the source text talks a lot about LLM-native software,
Yes.
which is a really interesting paradigm.
It is. LLM-native platforms operate on a totally different philosophy. They maintain a very solid, battle-tested core application, but the interface and the functionality are almost endlessly extensible just by asking the AI to change them.
Wow.
Yeah, the application is designed from the ground up to be modified by natural language.
So you are literally speaking code into existence.
Basically, yeah.
Like Pi is a great example of this from Morrell's piece. Instead of the developers trying to cram every conceivable feature into Pi's core application, they just built stable hooks.
Right. Hooks for tools, commands, the UI.
Exactly. So when a user asks for something completely unique, Pi doesn't just give a text answer back. It actually generates a small TypeScript extension, injects it into the application, and reloads it in place on the fly.
Which is wild when you think about it.
Yeah.
And DeepSeek demonstrated a very similar capability.
Yeah.
They showed off an environment where a user just prompted the system to add a whale friend to their screen.
A whale friend?
Yeah. And the system wrote the code, rendered the whale, and then the user asked it to add a fully playable snake game directly into the UI. And it just worked.
Just adapted instantly.
Yeah.
That's incredibly cool to watch. You speak, and suddenly there's a whale, or you're playing Snake. But I do have to push back here a little bit, because there is a glaring limitation to these early examples. Like, this sounds amazing if you are a developer or a power user who is completely comfortable running experimental, hallucinated local code on your own machine.
Right.
But let's think about, like, an accountant.
Oh, boy.
Or a lawyer handling sensitive client files. If an accountant started using an AI agent to hallucinate custom financial macros that execute locally on their laptop, their IT department would have a collective, catastrophic heart attack.
And it would be an entirely justified heart attack.
Right.
Absolutely.
Yeah.
Because the applications we just mentioned, things like desktop AI agents, developer IDEs, video game mods, they currently have a very high barrier to entry. And they mostly run locally.
Yeah.
The fundamental danger there is that unless you are highly skilled at manually sandboxing them yourself, those extensions run with full local permissions.
They can see your files.
They can see your files, they can access your network. They literally have the keys to the kingdom.
It's an IT manager's worst nightmare.
Com-
You're essentially asking them to rubber stamp software that no human being has ever looked at, and honestly, no human being will ever look at.
Exactly. For professions handling sensitive data, they desperately need these bespoke tools, but they need them to be safe by default. And that brings us to the central thesis of Morrell's piece.
Which is?
To truly democratize this power, we have to move away from local desktop agents and bring extensible software to the web.
Because the web is already the most successful software distribution system in the world.
Exactly. It abstracts away all that local installation complexity and danger.
So if we can build web applications with a secure, accountable core and then allow users to safely extend them in any direction using LLMs, we are essentially handing everyday users superpowers.
Superpowers, yes.
Let's take this out of the abstract for a second and visualize what those superpowers actually look like. Because Morrell shares his own personal wish list for web-based extensible software.
Right, and his examples really highlight the difference between a generic feature and software for one.
So take his idea for our Read It Later app.
Okay.
He wants a custom rule that automatically sends every article he favorites that is over 4,000 words directly to a specific e-reader.
That is a highly personal workflow.
Right. No developer is going to build a native toggle in their app for send to Jeremy's specific device only if the word count is over 4,000.
Never. Or another one he mentions is for academic research. He wants an automation that monitors ArcViv for new papers in his specific subfield.
Okay.
But instead of just sending him a link, the automation should pull the paper, inject a custom AI summary that specifically compares the new research to his own ongoing projects, put that summary at the top of the document, and tag it.
Wow. Yeah, trying to get the developers of an academic database to build that exact integration just for him is literally impossible.
Right. And he also looks at this from the perspective of an enterprise support technician.
Oh, this is a great one.
Yeah, a technician spends all day digging through dashboards and system logs. Morrell envisions a support platform where that technician could just spin up a custom button on their interface that says, reset quota X.
Just for them.
Specifically tailored for their unique flow of daily support tickets.
This specific enterprise use case is where things get really complicated, though, right?
Oh, very.
Because we are entering the era of the internal corporate platform. Companies generate just mountains of data, and employees constantly need to query it. And right now, companies are seeing a massive surge in employees vibe coding their own tooling to solve these problems.
Yeah, vibe coding is such a great term.
We should probably define vibe coding for a second.
Yeah, let's do that.
It's basically when you use an AI to intuitively generate a script or an app without actually knowing how to write the syntax yourself.
Right.
It's like telling an AI, make me a button that finds all the customers who haven't emailed us in 30 days and highlights them in red.
Exactly. You don't know the SQL query.
No.
You don't know the JavaScript rendering logic. You just know the vibe of the result you want, and the LLM figures out the mechanics.
But employees are doing this constantly, and they are deploying these little AI-generated apps to cloud platforms to make their jobs easier.
Which is incredibly empowering for the employee.
But it creates absolute chaos for the company's security posture.
Complete chaos.
Suddenly you have hundreds or thousands of these rogue applications just floating around the corporate network. It's the IT heart attack all over again, but now it's happening in the cloud. Like, how do you track these apps?
Right.
How do you know what database credentials they are using?
Or more importantly, how do you ensure they only have access to the data they actually need?
Yeah.
Because if an employee's vibe-coded app uses a broad access token to read customer records, what happens if that token leaks? Or what if the AI hallucinated a line of code that accidentally logs those customer records to a third-party server?
That is a massive GDPR violation just waiting to happen.
Absolutely. Which is exactly why Morrell argues a true extensible web platform is necessary.
To provide a controlled space.
Right. An internal platform team can handle all the incredibly complex stuff, the compliance, the security protocols, the data access boundaries.
The guardrails.
Exactly. And within that heavily fortified sandbox, employees can freely and safely use LLMs to build their custom automations.
But, okay, if that vision is so clear, it raises a pretty obvious question.
Why isn't everyone doing it?
Yeah, why isn't every web app already doing this?
Because running arbitrary user code on your servers is terrifying.
Yeah, Morrell actually uses the phrase, "here be dragons."
And he's not exaggerating at all.
No. To understand the dragons, we should look at Obsidian. Obsidian is a massively popular notes app, and it is wonderfully extensible. You can install plugins that turn your simple text notes into a complex relational database, or hook it up to a vector engine for semantic search.
But Obsidian operates on a high-trust model.
Meaning what, exactly?
Well, when you install a plugin in Obsidian, you are trusting it completely. That plugin can essentially do anything on your local machine. It can read your file system, it can connect to the internet.
Okay, so that trade-off makes sense for a local notes app used by a technical community.
Sure. But that high-trust model falls apart the absolute second you try to apply it to web software.
Great, because if a web app holds private messages or financial data or customer healthcare records, you cannot just let an AI write untrusted code, run it on your server, and just hope for the best.
No, because the dragons are not just malicious hackers.
Right.
The dragons are often innocent users making completely mundane mistakes.
Which brings us back to that Heroku story from the beginning of our deep dive.
Yes, the infinite loop.
Yeah, there was an engineer at Heroku, which for those who don't know is a major cloud application platform.
Yeah.
And he shared a story about a very popular getting started tutorial for Python.
Yeah.
The tutorial told new users to deploy a simple application that was literally just an infinite loop. While true, print hello world.
It's a classic first programming exercise. You just want to see the text pop up on your screen.
Right, but when a user deploys that exact same loop to a cloud platform, the mechanics change entirely. Because from the cloud server's perspective, a brand new app just appeared and instantaneously started spewing millions of lines of logs per second forever.
Because cloud systems try to capture, process, and index every single print statement.
Exactly. So this tiny beginner script starts consuming massive amounts of memory and internal bandwidth until the system literally chokes.
It is an accidental denial of service attack caused by someone just following a beginner tutorial.
It's wild. And that perfectly illustrates the strict security checklist Morrell lays out for running user code on the web.
Right. So if an infinite loop can take down a server, the very first hurdle is resource control.
Okay.
You have to be able to put a hard limit on compute time and memory consumption before the AI even writes the first line of code.
Makes sense. Second on the checklist, if the code does have access to API keys, it cannot be allowed to forward them to an unauthorized third party.
Right. And third, you have to prevent the code from being abused to launch a denial of service attack against someone else's server across the internet.
So no outbound spamming.
Exactly.
Yeah.
You also have to protect against hardware-level vulnerabilities like Spectre.
Okay, wait, what is Spectre really quick?
So Spectre is a speculative execution attack. Modern CPUs try to guess what code is coming next to save time.
Oh, okay.
Right. And malicious code can trick the CPU into guessing wrong in a very specific way that leaves traces of other people's data in the CPU's cache.
Wow.
So your platform has to isolate memory at such a deep level that code cannot exploit the physical hardware to read a neighboring tenant's private data.
That is intense. And finally, a very modern problem on the checklist, crypto mining.
Oh, of course.
If you give people free compute power on the web, they will absolutely try to use it to mine cryptocurrency.
Always.
You have to be able to detect and stop that instantly.
So it is a daunting checklist.
It is, but I feel like I have a pretty logical solution for a lot of this.
Okay, let's hear it.
Tell me why this wouldn't work. Let's say I have this AI-generated code. Why can't we just give the code a restricted API key and route all of its outbound internet traffic through a proxy server?
Right, the proxy approach.
Yeah, the proxy just sits in the middle, checks the headers of every HTTP request, verifies the token, blocks anything that looks suspicious, and we're good to go.
So that is the most common solution engineering teams try to build today.
Yeah.
And it is fundamentally flawed.
Okay, why?
Providing what we call ambient I/O, like giving the code the ability to use a raw fetch command to access the public internet, is incredibly dangerous, even with a proxy.
But if the proxy is checking the URL and the headers, why does it matter if the code has a generic fetch command?
Because malicious code is endlessly creative. Even with a proxy, if the code can connect to the internet, it can potentially post your sensitive data to an outside server disguised as a legitimate request.
Oh, I see.
And furthermore, let's say you want to restrict the code so it can only read one specific email thread.
Okay.
There is generally no API token in existence that is that narrowly scoped.
Hmm.
Most email API tokens give you access to the whole inbox.
Ah, okay. So I'd have to write custom logic in my proxy to enforce that specific restriction.
And that's exactly where the proxy idea falls apart. Now you are writing a proxy that has to parse an opaque token, figure out what the user is allowed to do, check the URL they're trying to hit, verify that the URL perfectly matches the allowed action, strip out bad headers, inject the real API key, and forward it on.
That sounds like a nightmare.
It is. You have to write filtering logic to anticipate every single edge case of a third-party API that is constantly evolving.
Yeah, that's impossible.
It's very difficult to test, and if you miss one edge case, a clever AI script can exfiltrate your data. Starting with a lot of power, like a raw internet connection, and trying to restrict it is just a profoundly hard computer science problem.
Okay, I concede. The proxy idea is dead.
Sorry.
No, it's good to know. So what's the actual solution to the dragons, then?
The solution is a paradigm called the object capability model.
Object capability.
Instead of giving the untrusted code a raw internet connection and a set of keys, you hand it a narrow capability.
Okay, I think I get this. Think of it like hiring a contractor to fix your kitchen cabinets, right?
Yeah, great analogy.
Giving the code a raw internet connection and an API key is like giving the contractor the master key to your entire house and just trusting them when they say they'll only stay in the kitchen.
Exactly, and they might wander into the bedroom.
Right. But the object capability model is like handing them a magic hammer that physically ceases to exist the moment it leaves the kitchen.
A perfect analogy.
Yeah.
In practice, a capability is a reference to a single, highly specific function.
Okay.
So instead of giving the code the entire email API and an API key, you inject a single function called getApprovedEmail.
So the untrusted code literally doesn't even know how to connect to the internet.
Exactly. You remove ambient network access entirely.
Wow.
The code can only take actions through the specific function references you passed into its sandbox. It never sees an API credential. And without an outbound network connection, there is no way for the code to leak your data.
It's a closed loop.
It's a closed loop.
There's actually another massive benefit to this that Morrell points out regarding the LLMs themselves.
Oh, yes. The context window.
Right. When you ask an AI to generate code using a massive OpenAPI JSON file, it's like throwing a 500-page legal dictionary at it.
Yeah, it gets overwhelmed.
Exactly. The AI uses up a huge amount of its processing context, its tokens, just to figure out how to format the HTTP request properly. It gets confused and it hallucinates bad code.
But if you just give it a capability, a single restricted TypeScript function like getApprovedEmail, it's like handing it a simple one-page cheat sheet.
Exactly. It is wildly more efficient and much harder for the AI to mess up.
It's better for security, and it's better for the AI. So the goal is clear. We need a highly secure, restricted, multi-tenant, programmable platform that uses these narrow capabilities.
Which sounds incredibly futuristic.
It does.
But this is where the history of tech gets really interesting, because this is not a pipe dream. Someone actually built this 2 decades ago.
Yes.
Morrell points to Salesforce as the ultimate precedent.
Which is funny because most people just think of Salesforce as a CRM, like a place for salespeople to log their calls.
Right. But Morrell argues it's much more accurate to describe Salesforce as a massive, multi-tenant programmable platform.
Because they launched this capability way back in 2007.
2007. Just for context on how early that is, Amazon Web Services launched their very first basic cloud servers in 2006.
So Salesforce was executing custom user logic at the absolute dawn of cloud computing.
That's incredible.
They built a custom Java-like language called Apex,
Okay.
and they allowed their customers to write custom logic that would safely execute directly on Salesforce's servers in response to application events.
So if a new lead came in, a customer's custom Apex script would run, calculate a score, and update the database.
Exactly. They essentially built a precursor to modern serverless technology.
But because it was 2007, they had to build everything from scratch.
Everything.
They built their own compiler, their own runtime, their own type system. They integrated SQL directly into the language so it was safe. It was this monumental engineering effort that took years.
Which brings us to today, because we don't have to build custom languages from scratch anymore. We have new primitives.
Thankfully.
Yeah. But to pull off this kind of secure, squishy software at internet scale in 2026, the underlying tech stack has to meet some very extreme requirements.
Okay, let's break those down. First, the economics have to make sense.
Absolutely.
You cannot spin up a heavy Docker container for every single user's custom script. If you have 1 million users, you'd go bankrupt.
The cost has to be $0 when the script is idle and fractions of a penny to execute.
Second is the cold start time.
Right.
If user code is running as part of a web request, say clicking a button to render a custom dashboard, it can't take a minute to boot up. It needs to start in single-digit milliseconds, or the user experience is ruined.
Doubly ruined.
Third, you need absolute control over those limits we talked about earlier: CPU, memory, log volume.
Because if that Heroku infinite loop happens, the platform needs to instantly sever the process without affecting any other user.
Yes. And finally, you need that rock-solid isolation boundary to prevent those hardware-level Spectre attacks.
Right. So what are the actual technology options today that fit that really demanding criteria?
Morrell surveys the landscape and identifies a few paths.
Okay, like what?
Well, you could use an interpreter, like embedding Lua or QuickJS into your app. It's very fast, but managing the memory safely requires a lot of manual C++ work.
Which is risky.
Yeah. You could also look at micro VMs like Firecracker or AWS Lambda micro VMs.
Oh, I've heard of Firecracker.
Yeah, they strip away all the heavy virtual hardware of a full operating system, so no virtual USB ports or graphics cards.
That sounds good for security.
They offer really strong isolation, yeah, but they still take hundreds of milliseconds to start, which is too slow for real-time web rendering.
Right, the user's just sitting there waiting.
Exactly. Another compelling option is WebAssembly, or WES, combined with WSI.
And WebAssembly is brilliant from a security perspective because it starts as a completely blank slate.
How blank are we talking?
By default, a WebAssembly module doesn't even know what a clock is, let alone how to connect to the internet or read a file.
Wow.
It perfectly matches that object capability model we talked about.
Yeah.
You literally have to inject the specific functions you want it to use. If you don't give it a network capability, it is physically impossible for it to make a network request.
That is a very secure sandbox.
Very. And finally, we have V8 isolates.
V8 isolates. Okay, what are those?
Well, Google has poured enormous amounts of money into hardening the V8 JavaScript engine for the Chrome browser. Think of an isolate, like a tiny self-contained brain.
Okay.
Instead of booting up an entirely new computer for every user like a virtual machine does, an isolate just spins up a microscopic instance of a JavaScript engine within a single process.
So it's much faster.
It takes 1 or 2 milliseconds to start. And if the user's code panics, only that one tiny brain dies, not the whole server.
Which brings us to the ultimate practical solution Morrell highlights in the piece. He narrows all of this theoretical tech down to the most production-ready, out-of-the-box framework available in 2026.
Which is?
Cloudflare Dynamic Workers.
Ah.
And they are built entirely on those V8 isolates. Now, Morrell does disclose that he works at Cloudflare.
Right, fair enough.
But the technical case he makes for why this specific technology solves our list of dragons is very, very compelling. Dynamic workers provide all the infrastructure you'd otherwise have to build from scratch.
Let's connect those features to the threats we discussed. First, dynamic workers have built-in OpenTelemetry.
Which is critical because AI-generated code is inherently a black box.
Exactly. If an AI writes a script for a user and it fails silently, the user has absolutely no idea why.
Telemetry acts like X-ray vision,
Yeah.
exposing the logs and performance metrics so the platform can automatically debug the AI's mistakes.
Second, they provide multi-tenant data storage via a feature called durable objects.
Okay, what does that give us?
This gives each user their own isolated SQLite database. The data boundaries are structurally enforced by the platform, which solves that enterprise data leak fear.
That's huge. Third, they offer something called durable execution.
I love this feature.
Yeah, because some user workflows take minutes or even days to complete, like an AI script waiting for a manager to reply to an approval email.
Right.
A normal server might reboot in the middle of a 3-day wait and you'd lose everything.
But durable execution saves the exact state of the script, survives the reboot, and wakes back up exactly where it left off.
It's basically magic.
It is. But the most important feature that ties this all together is hosted LLMs, specifically Cloudflare's Workers AI.
Because this solves the ambient network access problem entirely.
Yes. Because the AI model is hosted inside the Cloudflare environment, the user's custom script never actually needs to reach out to the public internet to ask the LLM to process data.
The capability remains totally sealed within the sandbox.
Exactly. And no outbound network connection means no way to exfiltrate GDPR data.
And to prove it all works, Morrell actually practiced what he preached.
He did.
He turned his own static blog into a mini vibe coding platform. He built a customizable web scraper using dynamic workers. You give it a URL, and it securely runs a custom script that you, the reader, can prompt an LLM to write right there on the page.
That is so cool.
Yeah, it proves that this zero-trust, highly flexible sandbox can actually be built and deployed today.
It is a brilliant demonstration of the core concept. We're moving from a world where developers build rigid software for the masses to a world where platforms provide safe, malleable spaces.
The user brings the need,
The LLM writes the logic.
and the platform safely executes it within a heavily guarded sandbox.
It's beautiful, honestly.
So what does this all mean for us? To summarize, the future of software isn't just about having an AI write a Python script for you to run locally on your laptop.
Right.
It's about our everyday web applications becoming fluid. It is the end of the one-size-fits-all Swiss Army knife. Web apps will adapt to your exact, highly specific needs, your read-it-later rules, your custom support dashboards.
Without compromising the security of the broader platform.
Exactly.
And it unlocks an unimaginable level of creativity and productivity for the end user.
But taking a step back from the code,
Yeah.
if we actually achieve this squishy software, it fundamentally breaks how we think about design.
Oh, wow. Yeah.
Because if I can just speak a custom dashboard into existence, what happens to the UX designer who spent 3 months carefully crafting the rigid menus we used to use?
That is a profound implication.
Right.
Because when an interface is no longer a fixed layout, but instead becomes a generative space that morphs based on a verbal prompt, are UI designers obsolete?
Or do they just stop designing buttons and start designing the physics of the AI sandbox itself?
The physics, yeah.
Defining the constraints of what the AI is allowed to generate to ensure it remains usable and doesn't devolve into a chaotic mess of overlapping text.
Right, they'll be designing the boundaries of the sandbox instead of building the castle.
That is a wild place to leave it. We started by looking at a rigid, unchangeable system, and we've ended up questioning the very future of how human beings will interface with machines.
Yeah.
That's the squishy future of software. Thanks for joining us on this deep dive.